Good evening and welcome to another Parkinson's Concierge webinar. This is from our series of the Parkinson's House. Tonight we are discussing living a life with Parkinson's and pain. And as always, we have got together some very distinguished guests on our show tonight. We have, in no particular order, Professor Ray Chowdhury, Dr. Kirsty Bannister, Siva Nadarajah, and Paul Chazo. So before we begin, I've got a couple of announcements to make, and then our guests, we're changing format this time. Our guests will actually start presenting some slides. One of the things that I'd like to say is, first of all, we hope you're staying safe and obeying the rules. We are pleased to have these four distinguished guests on our panel this evening. However, we need to point out that we have no particular affiliation to the guests or the organizations they work for or represent. The reasons why we have brought the expert panel together is purely for the benefit of the Parkinson's community as a whole, to help understand what causes pain issues and in turn, what changes they can make to their lifestyle and share recommendations of the do's and don'ts to improve your pain journey and in turn to improve your quality of life. As always, we try to share our charity of the month, and this month we are very pleased to be supporting Elizabeth Idle at Cure for Parkinson's. She's raising money for the ping pong Parkinson's trip in Germany. So we understand that times are very hard for us all, but if you can, or if you'd like to donate, that's where the donation will be going. And there will be a link to that particular organization in our details about tonight's show. So without further ado, I believe we're going to start off with Professor Ray Chowdhury. Are you there? Hello, Ray.
Hi, thanks very much. Sorry, my Wi-Fi suddenly went off. I'm sorry about that.
No problem at all, sir. We'd like to hand over to yourself to start the presentation. And as a guest of our previous presentations, you'll see that we have made a change to tonight's format by allowing the screen shares for you to show us.
Okay, Russ, I'm very sorry I missed the introduction completely because of my Wi-Fi. Could you just, I'm just gonna give a broad high-level overview about pain in Parkinson's. Is that all right?
That's fantastic. Thank you so much.
Okay. Sorry. Okay, for the sake of time, I'll try and be brief because I know there are several people who would like to also in the panel who like to talk. So it really gives me great pleasure today to talk to you about a little bit about the problems of pain in Parkinson's disease or pain in people with Parkinson. I'm just trying to get my slides to go on to the full slideshow, which it isn't doing. Did it? Let me just stop sharing and I'll share again.
Chaudhuri, you want to click on that small icon next to the 37%? That little small icon.
Yeah, my problem is that my screen at the bottom is blocked by the share, pause, annotate, remote control, that one. So I can't actually. I'm trying. I think I managed to. Yep. Okay. Fine. Thank you for that. And now I think. Sorry. Thank you. I'll go over that very quickly. You will hear a lot about pain today, and my role is really to tell you a little bit about the high level of what a problem it is for people with Parkinson's. Very privileged here at King's College to have some fantastic colleagues, and you'll also hear from Kirsty Bannister, who's one of my colleagues working on some groundbreaking area of pain measurement in Parkinson. I think it's just touching on history. I am in London, so it's very relevant that the person who described Parkinson's disease, Dr. James Parkinson, who lived all his life in London, and that's his house. Those of you are familiar with London, 1 Hoxton Square, it is now a pub. No, actually, it's not a pub. It's a salsa club called Cuba. And before that, it was called the Bills. But anyway, if you went there, that room you see on the first floor is where he wrote the essay. And as you know, it is now over 200 years back that this was published. And why am I talking about Dr. Parkinson in particular is that he's the first person who described pain in Parkinson. And in fact, if you look at the essay of the shaking palsy, which he wrote so many years back, in his first, he described 4 people who we now know had Parkinson's. In his 4th case, he describes that the right arm was where the palpitations began, in other words, the tremor, but actually was afflicted by quite severe pain, rheumatic pain, he calls it, in the beginning. So in fact, not only does he describe pain, but he also describes prodromal pain. We now know that pain, along with several other non-motor issues, could be the part that occurs even before the tremor, the stiffness, and so on, that occurs in Parkinson's, that takes people with Parkinson's to their doctors or nurses for the diagnosis to be made. So pain was described by Dr. Parkinson well over 200 years back, subsequently by many others. I've quoted Gowers here, and a review paper that was written by Blair Ford in the early part of 2000, calling it the hidden epidemic. And the reason why it's been called a hidden epidemic is because it's a very common problem. Now, this is a review paper that I took part as part of a task force on pain in Parkinson's we published a few years back. And you can see here the list of all the different prevalent studies that's been properly done and published, but with differing methodology. In other words, some use specific pain scales, others did not. But overall, it appears that anything between 40 to 85% of people with Parkinson's will have some degree of pain. So it's very, very common indeed. And depending on how you're measuring this pain, and you'll hear about this from the other faculty members. And the other thing to remember is, when does pain occur? A lot of my neurology colleagues think that pain in Parkinson's only occurs very late in the condition. Completely untrue. Pain can occur, as Dr. James Parkinson pointed out, even before the diagnosis is made, to the late stage of Parkinson's. So it's ubiquitous. It's present we see it in people with very early stage of Parkinson's, people who are untreated, just come to the diagnosis, to the very advanced and even the palliative stage of Parkinson, where pain is also prevalent. But what is very important is going to the more granular details now. It's no good anymore to say a Parkinson patient has pain. Well, what does that mean? We need to really get into the detail of what type of pain it is, because the management varies from differing types of pain. And just as an example here, this is a study from Queen Square where they looked at the brain bank, and they went to the diagnosis. These are people who had confirmed diagnosis of Parkinson's because it was through the brain bank. But almost 18%, 21% had presented with non-motor symptoms first time. And in many, pain was the first symptoms. People were thought to have frozen shoulder. They went to the rheumatologist. The rheumatologist gave them shoulder injections a few times. your frozen shoulder will go away, but it didn't. What happened thereafter, that the person developed stiffness, bit of tremor, and then the penny drops. Aha, this might be Parkinson. So that's really worth remembering. And this is another very nice study from my colleague Anata Shrag from Royal Free and UCL. In this graph, you can see in red other people of shoulder pain here, those who had Parkinson's versus a control group. And you can see that when the diagnosis is made, which is this reference point at the end, like at the point 0, that people with Parkinson had shoulder pain up to 10 years before their diagnosis is made in this study. So pain could be a prodromal feature. Remember, before the diagnosis is made, they may not have any tremor, they may not have bradykinesia, they may not have stiffness, they may not have all the other classic motor features of Parkinson. So pain could still be there up to 10 years, according to Aneta's study, which was published in Lancet Neurology not long back. Just staying on with this, some other points to remember is the different types of pain. So here, I will just show you a brief video of a type of pain that we described a little while back, how different pain can be. This is the so-called unexplained lower limb pain syndrome. Let's hope that this video plays.
Mr. Garrett, just describe the pain that you've been just telling me about a little bit.
Okay, Professor, it's pretty consistent in the left leg, which is the leg that shakes.
Right.
And most of the time it simply hurts, a dull pain, which is exacerbated by long hours of inactivity, such as sleep. So that when I actually get up in the morning, not that I actually sleep very well, but when I actually get up in the morning, it's a struggle to motivate myself.
And so the pain doesn't really fluctuate that much. It's sort of there most of the time.
No, it certainly doesn't fluctuate. It's an ache rather than acute pain.
Right.
So I'll stop there. And I think it's important to point out several things with the late Mr. Garrett, who now sadly passed away, said. One, the pain occurs mostly in the leg that shakes, in other words, more affected side, but it doesn't fluctuate and it interferes with his sleep. It also, now we know, pain has a huge effect on insomnia, on daytime, concentration, attention. Pain is also associated with depression and also anxiety. So it's not just pain. It gives you a really, really complex picture of how it affects various other non-motor issues as well. And this particular syndrome, where you get this lower limb pain, is actually pretty common. We see it often. And people might present with pain in the upper thighs and the pelvic areas. They have lots and lots of different tests by the orthopedic doctors, by the rheumatologists. They have MRI scans and so on, but it needs to be recognized that this is a specific type of pain that we see in Parkinson's. And why am I talking about it? I'll come to it in a minute. Before I end, we also now recognize that Parkinson can come to us, or somebody with Parkinson, with specific subtypes. And the idea that Parkinson patients are all the same is long gone. That's very old-fashioned. So we need to understand one size doesn't fit all. Some people with Parkinson's might have a particular problem with sleep disorder. They might be falling asleep while driving or other things. They fall into the so-called Park sleep group, whereas another group we've identified, and hopefully Kirsty's testing will tell us more, background or more granularity into this particular phenotype, is the Park pain group. Here we see people who are dominantly troubled by pain, like you heard from Mr. Garrett in that video. And we now know that this particular Park pain group can be associated with many other features, particularly, as I said, sleep dysfunction. They might need some very specific types of treatment. And I will go over this now very quickly. We also know, and this is an interesting study from my colleague Olivier Rascol in France, showing in the top panel, you see those all large red areas. This is when the levodopa, or this classic treatment of Parkinson, is not working very well. So the person is off And as soon as the person enters an on phase, which is the second panel, you can see those red marks have quite dramatically disappeared. In other words, as you overcome the pain also by giving dopaminergic treatment, you can also change cerebral activation in the differing centers of the brain. So their pain therefore has a central origin and a peripheral origin in Parkinson. How do we measure it? Well, one of the first scales is the King's Parkinson Pain Scale. This is now routinely being used in the clinical trials. It was developed by us from King's with an international collaboration. It divides pain into 7 subtypes, 7 groups, and that is why it's important to recognize the pain. Is it musculoskeletal pain? Is it chronic central pain? Is it peripheral pain? Is it pain in the face, orofacial pain? Some people with Parkinson have burning mouth syndrome. Is it fluctuation pain, like pain that only happens when the person is off, you give them levodopa or other treatment, the pain goes away. This scale is able to measure that, and if the doctors or the nurses or yourself may not have time to measure it, you can use the questionnaire, which we now routinely use. The great thing about the questionnaire is actually completed by the patients and the carers themselves. So it empowers our people with Parkinson to tell us about pain. It links with the scale. And I would definitely recommend that if you do have problems with pain, that you complete the questionnaire and just take it to your doctors or nurses or others who are looking at it, because this will allow you to declare the different types of pain. Again, 14 items, simple lay English. The format has been actually agreed upon by an expert patient group of Parkinson's who proved this. This is now widely available around the world. So the King's Parkinson Pain Questionnaire is specifically designed for you to complete and declare your pain yourself to the healthcare professionals, in other words. Some other quick aspects about pain. This is COVID and pain. What we have seen, and this is a small piece of work done by my fellow Katerina Rukavina, who's working with both myself and Kirsty in a PhD program on pain. You can see the green bars I'd like you to see. She used the numerical rating scale for pain. It's something you can use on the phone because we're only doing virtual follow-up. What we see in the top panel is since the COVID-19 lockdown, self-declared pain scores in people with Parkinson has increased substantially. And why is that? Well, we don't know the answer. It could be that lack of exercise. It could be the muscles are more stiff. It could be that you're not having enough walking outside or your usual exercise pattern. Also, it's worth remembering that if somebody's more anxious, somebody's a bit more stressed, the experience of pain is worse. So there is that issue as well to remember, that the COVID-19 pandemic has also had an effect on the experience of pain in people with Parkinson, particularly those who are shielding or those who are obviously in a housebound because of lockdown. I think I would not go into the details of treatment, just suffice it to say that management and treatment of pain is incredibly complex. And we will probably hear about that from the other members of the faculty. But it's worth remembering that you have both pharmacological options and non-pharmacological options. They're both equally important. It's not just about tablets. And once again, I'll repeat, one size doesn't fit all. You have to individualize the treatment based on the person's scores and needs. Modern treatment of Parkinson's, modern neurologists, modern geriatricians, modern nurses all need to do that. We need to go away from this old-fashioned one umbrella treatment for all. That's just not acceptable anymore. A couple of new trials. It's very important that the industry has woken up to it. And for the first time, since we started with the pain scale and so on, we're seeing some specific clinical trials in pain. So this is a trial called the Ocean, which is going to use the drug opicapone and look at the effect of pain of this drug, simple one tablet with placebo. This trial we are going to be leading on, and that will happen very soon, hopefully as soon as the lockdown and the face-to-face consultations are allowed. Similarly, there is also another trial which is using another drug called Spinamide, and there's some preliminary data suggesting Spinamide, which works on the glutamate system in the brain and the periphery, can also be effective for pain in Parkinson. And there is small initial signals suggesting that might be the case. There is also some very exciting development that we will be starting, working in collaboration with Kirsty Bannister, of vestibular stimulation. This is wearing headphones. The headphones give you hot and cold stimulation into the ears. This has been of dramatic effect in people with migraine. And we're now extending its use to Parkinson, and will be the key center in the UK to start this, along with 16 centers in the US. FDA has already approved this device. And essentially, you can wear the headphone for half an hour while lying and doing whatever you want at your home. And we are hoping that this will have quite an impressive effect on pain. And we'll try and measure that, not just by just scales, but also through measurement through wearing a wristwatch like a sensor, but also through the technology that Kirsty Bannister has pioneered in terms of measurement of pain in Parkinson's. So that's another very, very interesting development, and we really hope that it works for our people with Parkinson. Finally, we have also collaborated with our colleagues in Taiwan to show that acupuncture can also be a very effective management aspect of pain. In this study, we also used functional magnetic resonance imaging to look at the pathways in the brain, and it shows that with acupuncture, while the pain scores went down, some specific pathways in the brain got activated. So we are having more and more insight into the different types of pain and how we're going to manage those in future. And I think that's basically all I had to show. I mean, it was just a very quick overview of where we are with pain, the importance of it, and that sadly, it still remains an unmet need. We need charities, we need our industries to invest money on pain, and not just keep on investing money on more and more neuroprotection trials where billions have been spent. And once again, we heard in the last 2 weeks, another 2 failed trials, yet we don't have a single good, high quality clinical trial addressing pain in Parkinson's. So I think that's something we need to keep in mind, and it's a plea to all of you, those who might be involved in fundraising. So I'll stop there and stop sharing my video. So thank you.
Professor Chowdhury, thank you so much. That's been an absolute honor to hear you say what I've been saying for a long time, that more needs to be spent on the non-motor symptoms, the hidden bits and the hidden symptoms that we're all suffering from. And in doing that, I firmly believe that providing a better quality of life in some cases would, if somebody felt better themselves, then the umbrella, which is Parkinson's and all of the symptoms that come along with that, can be addressed. And again, it's our honor to hear what you've got to say. And it's given us a greater understanding of pain. So with that, I'd very much like to hand over to Kirsty Bannister, who works, I'll just be 1 second there, following completion of a BSc, MRS and PhD qualifications at University College and Imperial College London respectively. Kirsty spent 10 years as a postdoctoral research fellow investigating novel disease-induced alterations in descending modulatory pathways. Kirsty Bannister, over to you.
Thank you, Ross. Let me just make sure I'm sharing my screen properly. Hopefully that's in view. Thank you for inviting me along to talk today. And obviously it's a complete honour to follow Ray, who has set up the scene for me really nicely with regards to what I'm going to speak to you today about. So my background is a pain neuroscientist. I do preclinical and clinical work, bench and bedside, with regards to pain. And today in particular, I'm just going to spend 15 minutes talking to you about pain and Parkinson's disease, with a particular view on the experimental quantification of pain, and therefore a really exciting study that I'm about to start with Parkinson's UK Research, with Ray as my close co-investigator, which will be to investigate the sensory profiles of people with Parkinson's disease, in order for us to really get a handle on why generating these sensory profiles is so important. We can first of all think about the nature of pain. So of course, pain is an entirely subjective experience. It's not linear. If any of us right now were to receive the same noxious insult to the elbow, a bang to the toe, none of us would perceive that pain in the same manner. Some of us would rate it very high. Some of us would say it was not so bad. And this is because pain is driven by sensory discriminative as well as affective motivational qualities, which is to say that it's driven, our pain perception is driven not only by the sensation of banging our toe, but also our emotions, which is why past issues such as fear, hopelessness, helplessness, or current issues such as anxiety and depression can lead one person to score a cut to the foot as an 8 and another to score a cut to the foot as a 2 on that 1 to 10 scale of pain. So if we think about getting our COVID vaccination, we might talk about the sensation of pain in terms of how sharp the needle was, or if we banged our elbow, how hard was the bang. But we will also think about, well, how anxious am I feeling about having this injection? Am I feeling particularly depressed today? And importantly, when we think about the way we're perceiving a painful stimulus, the words we use really give you an indication of which of those pain descriptive qualities we are relying more heavily on to have that particular perception. So sharp, stabbing, burning, piercing will relate more to this sensory discriminative aspect, whereas uncomfortable, consuming, relentless, unpleasant, that's words that really are linked to your affective motivational aspect of the pain experience. What's really crucial to remember is that we cannot have a sensory discriminative pain experience without an effective motivational one, and vice versa. So when we think about pain, we're talking about a perception that has multiple levels, multiple layers of complexity. And this is why it's an entirely subjective experience. So therefore, that answers more or less what the problem with measuring pain in people is that it is so subjective. And traditionally, when we think about asking individuals to rate their pain on a scale of 0 to 10, or we ask them to point to the face which best incorporates the pain that they're feeling at that one moment, we're talking about an entirely subjective pain measurement tool, which doesn't adequately account for the individual's emotional status, nor does it adequately portray the level of pain that an individual is experiencing. And so slowly but surely, when we think about pain neuroscience and we're trying to link underlying mechanisms of pain to a pain readout in an individual who can give us a pain score, for example, we're moving towards a solution which is to conduct a physical examination of the individual in order to generate a sensory profile. So there are two types, well, there are many different types of tests. I'm going to talk through two types of the tests that we can do to achieve this. So one is quantitative sensory testing, whereby we apply filaments of increased bending force, as shown on the top right picture, or we apply pressure, increased pressure as shown in the middle, or a sharp needle type apparatus to the hand. And as the stimulus intensity increases, we can ask that individual, are you able to detect the stimulus? Is that stimulus now becoming painful? So that's telling us about your pain threshold. So what level of bending force do we need to apply before you say, actually, for me now that's painful? And then we go one step further and we keep going until we say, well, have you reached your tolerance threshold? So we can gain information regarding how well you detect a sensation, when that sensation becomes painful, your threshold, and also when you can no longer tolerate that pain anymore. The second test we can do is called conditioned pain modulation. And this is where two stimuli are now applied separately and then concurrently. So you can see on the left here of the picture, we show various test stimuli. Some of them are like the ones we showed in the slide before. So we're applying filaments to the skin, we're applying pressure, we're asking individuals to tell us when they find that painful. And then at the same time, we can apply a conditioning stimulus as shown on the right. And this could be hand immersion in cold water, hand immersion in hot water. And when we apply those stimuli, we say, does the pain generated by your test stimulus lessen when the second conditioning stimulus is applied? So is there an effect on the system whereby a conditioning stimulus lessens the pain you associate with the test stimulus? And this is a measure of the well-known phenomenon that's called pain inhibits pain. All of us have naturally occurring inhibitory pathways, which mean that we feel less pain upon application of certain noxious stimuli. For some of us, those pathways are much more functional than others. If we can combine the quantitative sensory testing data, the condition pain modulation data, and the questionnaire data relating back to what Ray was talking about previously with the pain scales, what we can do is generate sensory profiles for the individual. So what does this tell us? Well, if we conduct a physical examination of an individual's sensory system, it allows us to understand if there's a dysfunction in their pain processing circuitry. So if I show you this picture here, this is a really basic depiction of the pain processing circuitry. So we might imagine that we've had a pinprick to the finger. Incoming peripheral nerves will convey that information in terms of the touch or the temperature of the stimulus to the spinal cord. And then we have a series of pathways that go from the spinal cord to the brain. In terms of ascending pathways, they take the pain message to the brain, and then a whole series of descending pathways, as shown here in red, that come back to this transmission system in the spinal cord to inhibit our pain, for example. So when we create a sensory profile, we obtain information about the functionality of naturally occurring pain inhibiting nerve pathways that project from the brain to the spinal cord. And I've highlighted just one example of them for you here. And this is possible for us to gain this kind of information when we apply conditioned pain modulation. We can also, by generating a sensory profile, understand about the functionality of these peripheral nerve pathways that project from the body, so from the hand or the foot, for example, to the spinal cord. So these are very distinct pathways. And what's really crucial to realize is that if we were to find that the naturally occurring pain inhibiting nerve pathways were inefficient, they were dysfunctional, then a therapeutic strategy would require enhancement of our ability to naturally inhibit pain processing, for example, through the use of noradrenaline reuptake inhibitors or serotonin reuptake inhibitors. Conversely, if the nerve pathways that travel from the body to the spinal cord were shown to be compromised with quantitative sensory testing, for example, then the therapeutic strategy would require peripherally targeted analgesic approaches. So how does this link to what we would like to study in Parkinson's disease? So I performed, my lab specialty is to measure a very unique type of inhibitory pathway shown here on this diagram in the right. And previously, the laboratory of Professor Susan Duty supplied me with rats that had a particular lesion that generates a model of Parkinson's disease in these animals. And what I was able to show preclinically was that in these animals, they didn't have functional inhibitory pathways. So these nerve signals that naturally occur and travel from the brain to the spinal cord to inhibit pain weren't functional in these animals. So I stepped back and thought, well, this could be an underlying mechanism of Parkinson's disease and or the chronic pain phenotype observed in these Parkinson's animals. So is this data clinically relevant? We can link the mechanisms in animals to humans. So in humans, we can use these cuff algometers in order to measure conditioned pain modulation. And this is a setup used most prominently by Professor Thomas Gravin Nilsson's laboratory. He's a real pioneer of this technology and my mentor when using this technology. And what we see here is a representative raw trace of an individual who, when we apply pressure, you see the gray bar in terms of as the pressure increases, so too does their pain score according to the visual analog scale. But then when we apply a second stimulus, that conditioning stimulus, what you see according to the red block is that the individual takes longer to say that they have detected pain, they can tolerate the pain for longer, and their visual analog scale score is lower. We've shown that this translates beautifully to an identical paradigm in the animals, where we see neuronal responses in response to the same conditioning stimulus pressure at 40 kilopascals induces the same inhibition of a pain-related neuronal phenotype. So with this in mind, it was clear that the predictive value of the laboratory model we used for human processing was high, and that we can obtain these directly comparable outcomes using equivalent cough pressures. So what's nice translationally is that dysfunctional pain inhibitory pathways have already been shown in patients with neuropathic pain and equivalent animal models, and these have been shown to be restored with the same pharmacologies. So this is when I approached Professor Ray Chowdhury with the idea that we should investigate the sensory profiles of people with Parkinson's disease. And I went to Parkinson's UK with a grant application which said, you know, we want to investigate a potential cause of constant pain in people with Parkinson's disease that may be linked to disease progression. Luckily for us, they loved the idea and they have granted the funding. So I, along with Ray and our associated team, will apply these two somatosensory tests to people with Parkinson's who do not suffer from persistent pain, a group who do suffer from pain, and their healthy sex and age match controls. So by performing the condition pain modulation tests in these individuals, it will inform us how well their naturally occurring pain pathways, inhibitory pathways, are functioning. And by performing the quantitative sensory testing, it will inform us how sensitive individuals are to non-painful and painful sensations. And we will combine this with the questionnaire data in order to generate personalized pain sensitivity profiles for each individual, which fits beautifully with what Ray was just saying in terms of no two individuals are the same, and everyone will generate a unique sensory profile because each is individual and unique. And this will guide knowledge of the mechanisms that underlie the constant pain and or the disease itself in people with Parkinson's. So we will apply the QST in order to have an overview of the sensitivity of the individual to light, touch, cold, vibration, etc. We'll apply the pressure device to understand whether an individual has functional brain spinal cord inhibitory pathways similar to what we did in the Parkinson's animal model. And then we will compare the profiles of healthy people to those individuals with Parkinson's disease with persistent pain, and compare these again to those individuals with Parkinson's disease without constant pain. So obviously we are not going to know the outcomes until we do them. I think there'll be multiple layers of stratification, but you can imagine a scenario where we have people with Parkinson's with constant pain who have reduced detection and tolerance thresholds compared to controls and those patients with no pain. This will give us an indication of the mechanisms underlying the pain itself. Or we could imagine a scenario whereby we have a reduced detection tolerance threshold compared to controls in people with Parkinson's, regardless of the fact of whether they suffer from persistent pain or not. And this gives us an indication of the mechanisms underlying Parkinson's disease itself. And all together, by creating these sensory profiles, the identification of any abnormalities will refine these tests for routine clinical use, develop these pain-specific personalized strategies for people with Parkinson's who suffer from constant pain, and aid the start of clinical trials of new drugs in order that appropriate treatments can be developed. So this is a really long view. This isn't something that's going to happen in the next year or two. This really is the foundation bed of what we hope will become a real guiding mechanism for understanding what pharmacotherapeutic strategies should be applied to those individuals with Parkinson's disease who suffer from constant pain. So thanking my group and my sponsors, but most notably for today, Parkinson's UK, the research team, which would be myself, alongside Ray and Tatum and Katerina, and the collaborators on the grant for Parkinson's UK. Most notably, I mentioned Thomas again. He is the spearhead for all of the human psychophysics testing that we do. Thank you.
Dr. Kirsty, thank you so much for that. That was very interesting. And I hope that our viewers enjoyed the presentation. I know I certainly did. And what you do within the community, thank you so much. We will be coming back to you shortly with some Q&As, but if I can now pass over to Siva, who joins us all the way from the East Coast of the United States. Siva is the president and co-founder of JOGO Health, which is a US-based digital therapeutics company that uses wearable biosensors and an AI, artificial intelligence, VR, virtual reality driven app to treat pain, incontinence, and 20 other neuromuscular conditions. Welcome, Siva, and thank you for joining tonight's panel.
Thank you, Russ. It's a privilege. I'm honored to be here with the prestigious team here. I'm not a physician, but I can explain things, I guess. So JOGO originated at New York University, NYU. We are currently part of Johnson & Johnson Innovation here in Pennsylvania. Our research partner is Harvard Medical School, but after hearing Dr. Chaudhuri and the team, I now feel I have to come to London to continue the research. Looks like that's where most of the magic is happening. We also just received our FDA clearance for generic indication to treat pain and a bunch of other conditions because this is non-invasive. I'll walk you through simply what JOGO is. JOGO uses a wearable. It's like a wristwatch that you wear for 45 minutes a day. And you have AI-driven therapeutic applications that either you can play with on a tablet PC or virtual reality. It uses a very old science, but it adds AI to it. The science behind JOGO is EMG biofeedback. That's the science, which has been studied for many years for many other conditions. So we combined EMG biofeedback with pain neuroscience education, which is an upcoming field where you teach your brain about pain. And then, of course, we have machine learning models behind the scene. I don't want to get complicate this. But the mechanism of action of this whole science behind JOGO is neuroplasticity, where you are rewiring your brain to be less sensitive to pain and also other conditions. To get a little bit into this, again, Parkinson's, we haven't still tried yet, but there is enough data to suggest that we could work on Parkinson's. I just want to clarify that. So what JOGO does when it comes to pain is breaks the pain, anxiety, muscle tension cycle in the body, right? Because let's assume that you have pain due to Parkinson's, or in our case, we have data on cancer pain, for example, where your brain has become too sensitive to pain, and the brain is telling you something's wrong in your body, so you have to take care of that. So that builds anxiety in the body and also muscle tension in the body, right? But by training the brain to be less sensitive to the pain, by teaching the brain, you can actually break the pain, anxiety, muscle tension cycle. And it has been shown that you could do that. And while doing that, it kicks in neuroplasticity in the brain. Basically, you're rewiring the brain, right? So it works on the opposite side too. Let's say somebody had stroke, right? You had a stroke and you had an accident in the brain. So the brain has now forgotten, or the channels are broken in the brain. So now the brain has forgotten how to control the muscle. By teaching the brain that the problem is in the brain, not in the muscles, the brain learns to rewire, right? You could actually reconnect the brain by teaching the brain, right? That's the essential part of neuroplasticity. An easy way to explain neuroplasticity is with this taxi example in London. I go back to London again. So this was a study done in 2012, where, if you come to New York, although all the chaos that happens in New York, the streets are perpendicular. So a taxi driver in New York finds it easy to navigate New York City. All he has to remember is streets and avenues. But when you go to London, you know how difficult the streets are. It's built long ago. But the taxi drivers before GPS days, they were able to navigate London by memorizing the entire London map in their brain. So when they did a scan of these London drivers, thousands of them, they saw the hippocampus of the brain was larger for all these drivers, cabbies in London, compared to the taxi drivers in New York or Paris, for example. So by working on this training, basically training the brain has become essentially bigger. On that part of the brain, they showed that the hippocampus was bigger. So it shows that the brain has the ability to rewire. and you can train the brain. This was a study, fascinating study. You could look it up. It was done, I guess, I'm not sure King's was involved in this, but Harvard and some of the university in London took this research. Let me show you how JOGO works. So this is a patient who had a couple of things was going on with this patient. He had a major accident, motorcycle accident. He also had stroke. This is just to demonstrate how this would work essentially for Parkinson's as well if you start the trials. He was not able to, after he came out of acute care, he went through physiotherapy where physiotherapy didn't help him, right? So he was not able to wear his shirt buttons. He could not brush his teeth. He could do any of these regular activities where regular rehab did not help, right? So now the physicians thought, okay, let's try this whole, biofeedback thing to train his brain. And we trained him on JOGO. So let's see how this works. So you could see that he's wearing this small wearable sensor in his body. It's not sending an electric current to the body or anything like that. It's just picking up the muscle electric signals. It's reading it from the muscle. It's talking to this application, which is running on a tablet PC. Now we are training him to hold the cup, right? So he's training basically his brain to hold the cup. Where brain is where the problem is, remember, right? The muscles are fine, but the brain has forgotten how to do this exercise. So we are training him with very specific protocol that was developed for this using this app, and he's holding it little by little. At the same time, he's also relaxing the muscle so the pain goes down. So there's two things happening in here. One is he's grabbing the muscles that were inactive. Also at the same time, he's relaxing the muscles to break the pain, anxiety, muscle tension. There are two things happening, right? So the patient went through about 3 months of therapy. I would say once a week. I'll show you the patient, how he's able to. So this is the patient. He works in a bottling factory, and he was the only breadwinner for his family. The hospital had asked him to go on disability. So now after that, we treated him. So now he's able to, you could see that he's operating with all the hands, right? So again, this is an example of not Parkinson's, I would like to reiterate again, but the science works in different ways. You could retrain your muscle and the brain and the anxiety cycle to recruit new muscles or even relax the muscles to relieve pain. So what's the evidence in Parkinson's, right? That's where we are all interested today. So this is a study done, again, not on Parkinson's, but cancer pain. I would like to iterate this because this is what we're going to start on Parkinson's as well. So these were palliative care cancer patients. It's a small study. The preset of the pain scale was 4.21. And after 8 sessions of biofeedback, EMG biofeedback and this therapy, the post-test was 1.92. And this group of patients were already on painkillers. They were on high painkillers, opioids, because they're cancer patients. So both the groups are already on opioids. So we are treating them on one with JOGO, one without JOGO. So the EMG, which is the muscle tension, has gone from 4.5 to 2.63. So end of the day, 67% of those patients, although they were on opioids, had 30% pain reduction, and 50% of them had 50% pain reduction. But the control group, which was also an opioid, had a 14% increase in pain intensity, right? So this has clearly worked even with when the effects of opioids are going down. You could actually treat these patients. And we found this even after 6 months, it was constant. So basically, it's the rewiring that happened is permanent, right? Which is a good thing. So it's not a temporary fix to the body. These are the PD-related conditions that there is literature on this science, right? Not all of them are pain. Urinary incontinence, we have really good literature that this science have been studied. Again, we are taking old literature, which has been done with these older machines that were created by the same lab. Pain, dyskinesia, we have dysphagia data, swallowing disorder, dysenergy defecation, which is chronic constipation, and erectile dysfunction. So there are data, again, smaller studies, very small case reports that we were able to find, but we're going to pick one of these, especially pain, and we're going to start a study on this. And there are other pain conditions that we have treated with this science. I mean, there are a bunch of them. This has really good data: tension type headache, or facial pain, fibromyalgia, chronic low back pain, arthritis pain, including trapezius pain, post-operative GI pain, pelvic pain, chronic pelvic pain. We have been treating patients successfully by combining these two science. But again, we can't boil the ocean with JOGO, so we're going to start with one study. The nice thing is the FDA has cleared us to do neuromuscular re-education, which is essentially the code that we could use here. So we can even conduct real-world studies. But the next step with JOGO is find someone like Kirsty or Dr. come to London and start a study on one of the conditions in Parkinson's pain. Pick one and try it out to see how this works without trying to do something big. And the evidence is there in the literature that this might work. So I want to give some hope to patients that we could probably, the nice thing is it's not invasive or anything like that. So we can try it out. There's nothing is going inside the body. It's like training your whole body to be aware of the physiology of the conditions, right? Russ, that's basically it. That's my presentation. Yeah.
Siva, thank you very much for your time and for joining us across the pond. We hope you'll hang around for the question and answer session coming up shortly.
Absolutely.
Before we get to the question and answer session, I'd very much like to introduce Paul Chazot, who joins us. He's an associate professor of pharmacology. He's the president of Durham Parkinson's UK branch, and he can be found most of the time, well, apart from lockdown, at the Department of Biosciences at Durham University. So welcome, Paul.
Thanks, Russ. Hello, everybody. Okay, hopefully the IT works. Anyway, okay, so I'm a pharmacologist by day, but I also dabble in other ways of treating pain. And in this case, we're talking about Parkinson's pain. And what I'm going to present in these next 15 minutes or so is what we can do now, which is very important, as you'll see, because NICE here in the UK are going to offer very few options for treating pain pharmacologically in the very near future. So we need something now and in the near future for treating and treating pain in Parkinson's and managing pain in Parkinson's. So I'm going to give you a couple of potential solutions now and into the future. Okay, and the previous speakers, Ray and Kirsty, have nicely introduced you to pain in Parkinson's and some of the physiology. So I don't really need to go into this. This is very much an introduction to Parkinson's and pain and the different types of pain we have in Parkinson's individuals. Again, King's College have really been at the forefront of giving us this very detailed description of pain in Parkinson's. So I'll rattle through this slide very quickly and move on to, again, introducing you to pain. And these are some images. I don't really need to really show you, those of you that suffer from pain, what pain's all about. And some of these images depicts the type of pain that you can have, both in the young and the old. It's a multifaceted, complex process, phenomena, as Kirsty described. It's very important. So basically, the pain process is very important to survive. We need pain. We need to be able to feel pain in our normal physiology to be able to react to potentially damaging situations. As Kirsty said, it's a sensory and emotional experience. And as you'll see, it's as well as those two, it's also a cognitive process as well. And so acute pain is very important and can be resolved very quickly. Potentially, we have medications to help with acute pain. And in fact, I would say as a pharmacologist, it's probably one of the most successful drug classes of all time for an indication, a clinical problem. But that's acute pain. Chronic pain is a completely different matter. It's a very serious problem generally. Chronic pain is, it's the major reason why you go to the GP generally. And it's also It's very prominent across the population. And as we've seen, again, Ray highlighted, the very high numbers of Parkinson's sufferers that have pain. And I've just given you some numbers in my local area. I'm up in the north of England, in County Durham, and we have about 200,000 people that suffer from some degree of chronic pain, and including some Parkinson's sufferers. So as Kirsty alluded to, we've got a sensory component, we've got a motivational, a sort of affective component, as we say technically, an affective component, but also we've got a cognitive component of pain as well. So the brain evaluates the pain signals coming into the brain, and it does modulate, block, or modulate that signal, and that's a very important process as well. So it's the brain has a very important part to play in feeling pain and modulating pain, all these three different levels. Okay, as I said, I'm up in the northeast of England, and this is the current problem with treating pain generally, as well as Parkinson's, but across the board for treating chronic pain. We have medications, and doctors prescribe, GPs prescribe, pharmacists prescribe medications, but basically, frankly, all the medications that we have are pretty rubbish, and basically, in fact, cause health problems and cause serious problems, and potentially can kill you as well. So it's basically the medications, the pharmacologists haven't done very well for chronic pain, in essence. And this graph on the left-hand side depicts that here in the northeast, and that arrow is pointing to roughly where I am, we have a very serious problem in prescribing opioids and other medications like gabapentinoids as well in dealing with chronic pain. And many Parkinson's sufferers are prescribed opioids and gabapentinoids, and as well as a range of antidepressant types of drugs. The main problem is for these medications is that they get in here in the brain, and we'll talk about that a little bit later when I talk about the pharmacological approach to treating pain or dealing with managing pain. Okay, so the very important component is there's a brain component, which is what Kirsty and Ray have actually been focusing quite a lot on, and explaining different ways potentially we can target pain centrally. But also you have to bear in mind that there's a very significant peripheral component, so outside the brain, outside the central nervous system. And pharmacologically, that's our second approach, which I'll talk about in a minute, is actually designing and developing medication that doesn't get in the brain. That's the strategy that we're adopting pharmacologically. Okay, so first of all, I'm going to talk about centrally. And as I've already alluded to, NICE, you may not be aware of this, but NICE have looked at all the evidence in terms of treating chronic pain and all the medications, and they've sent out a discussion document last year, which many of us commented on, and it's gone back to NICE, and they've come up with this document that suggests, based on the evidence, that opioids, all the opioid medications, all the gabapentinoids, IV corticosteroids, and IV lidocaine basically are ineffective in treating, generally ineffective in treating chronic pain, apart from potentially some individuals do get some benefit. I don't want to flag up that it's across the board. Some people do get some benefits from some of these medications, but generally speaking, they are going to potentially ask GPs not to prescribe any of these medications in the future for chronic pain, and that will include people with Parkinson's. Okay, perhaps the antidepressants, there is some evidence-based antidepressant types of drugs are effective in some individuals. Again, that's going to be part of the documentation. And NHS England has just announced that there is a priority to actually get opioids down to 0 by 2024. Opioid prescriptions away from cancer pain down to 0 by 2024. Okay, so GPs and prescribers will need an alternative to treat chronic pain pharmacologically with drugs. So this is the strategy for now. This is what we need now. We need an alternative to medications because they're frankly, it's very poor medications for treating chronic pain. So this is our strategy, what we've been developing over the last couple of years. This is a strategy based on biopsychosocial approach. So it's basically, if you want to put a fancy phrase to it, skills, not pills. So it's basically training GPs and prescribers to have good discussions with their pain sufferers and working out the best way that they can actually manage their pain. They have to realize that their pain is there. They can't treat it, they can't cure their pain, but they have to manage it. And that's the same for Parkinson's sufferers as anyone else. So we've designed this toolbox for GPs to be able to have that conversation and be able to discuss the individual and their life and their environment to actually come up with the best strategy for that individual. As Kirsty said, it's a very individual, pain is a very individual phenomena. So it has to be designed for each individual patient to have that conversation and have strategy. So we've designed this, what's called a 10 footsteps approach. Again, this is all freely available and accessible for anybody to have a look at, and recommend you do. So this is what's called a gabapentinoid and opioid toolbox. Again, a fancy acronym, GOT. But again, the strategies behind it is based on these 10 footsteps. And I'm going to very quickly rattle through these 10 footsteps. Again, if you're interested, and I strongly recommend you have a look at our website, the Live Well with Pain website, which I can flag up after this webinar. So I'm just going to rattle through the different footsteps that we have within this strategy to get people to think about their pain in a different way. Can they change the way they carry out their life, their environment, to improve the way they can manage their pain, so they don't have to rely on medications. As I said, medications are going to be taken away from them in the very near future, so that they need other strategies to deal and manage with their pain. So building knowledge of the pain, so you need a knowledge base, like with Parkinson's, you need a knowledge base of what Parkinson's is about or what pain's about. Second step is incredibly important, acceptance that actually the doctor's not going to basically give you a magic pill that's going to relieve your pain. So it's acceptance the pain is not curable at this stage and won't be for the foreseeable future. And you have to think of different other strategies to manage your pain. Pacing is very important. So pacing the strategies that you adopt to overcome the pain, pacing is very important. Don't go too quickly. Pace yourself. Setting goals, realistic goals to achieve that pain management strategy. Can you change different parts of your life and your surroundings and your different patterns of existence? Can you set goals that are manageable over set periods of time? Very important. Exercise is actually the one thing that NICE actually said. There's a strong evidence base. Being active, exercise, getting active is extremely important to relieve, manage pain. Managing moods, again, I think, Ray and Kirsty mentioned this, being able to manage your emotional state, your mood is a very important footstep. Sleep is a really important footstep. It's one of our 4 key footsteps. Sleep patterns and sleep is incredibly important for managing your pain. For various reasons, the physiology of pain, the emotional state of pain, as well as the cognitive aspect of pain, sleep is fundamentally important for that. So a good sleep regime and ability, and again, strategies we build into our toolbox to give you ideas of how you can improve your sleep quality. Food, your diet, relationships and work, the social elements, again, are all built into the toolbox. Can we design different ways of developing your relationships and your work surrounding work regimes? Relaxation, mindfulness, again, is sort of a bit of a no-brainer. Relaxing, mindfulness strategies are built into this. And the very important last footstep is managing setbacks, because it's not an easy process to come to manage your pain, and there will be setbacks, and it's understanding there are setbacks. So these are the different footsteps. And I just want to flag up, because I'm conscious of time. So our early data, so we have used a large practice in Darlington, which is actually had the highest prescribing of opioids in County Durham, and therefore in the whole of the UK. And this is our current situation with introducing this toolbox and this training process. So this is when the program was introduced for the gabapentinoids. You can see a really significant drop in high dose gabapentinoids and pregabalin, and very significantly the opioids is on the bottom graph here. The green line is actually the national average. So this is high dose prescribing opioids. We've got well below the national average in a matter of 8 months of bringing in this regime. Okay, so these are the ones we've targeted, because the high dose are the ones that potentially can have serious health problems and potentially can kill people. So that shows you the early success of this type of program. We followed it up with developing a virtual Footsteps Pain Festival, which is live now. And again, if you're interested, you can have a look at it and the different activities that build on the Footsteps idea within a virtual site that again is freely available to anybody. Okay, so that's the first approach. The second approach is a pharmacological approach. Okay, this is for the near future, because at the moment, as I said, medications are very bad. We have very poor drugs that we can prescribe that's effective and safe to treat people with Parkinson, including Parkinson. Treat pain, including Parkinson's. As I've said, the main problem with current drugs is they get in the brain. All the issues with opioids, all the gabapentinoid issues, antidepressant issues, is because it get in the brain. So our strategy for many years, and we've been working in non-motor symptoms in Parkinson's for many years. So we've worked, just as a quick aside, on things like attention deficits and memory problems, narcolepsy and delirium in Parkinson's. And that's where we will target the brain. And this is the drug that we're currently working on that has huge potential in these areas of Parkinson's. But in terms of pain, we need to stay out of the brain. So the strategy is to find a rational drug that stays out of the brain but controls the pain transmissions that, again, Kirsty and Ray introduced very nicely in the talk. So these are two drugs that we've been working on. And it's based on my favorite molecule, which is here, histamine, which you might think is an unusual molecule to target, but histamine is very important in the brain. It's very important in all these facets of attention, narcolepsy, and delirium in the brain. But in the periphery, histamine is also extremely important in controlling pain sensation. And we did this many years ago, where we identified where the receptors are for this histamine in the pain pathway. So they're out here in the periphery. So this is skin. So you find the expression of this particular receptor, this histamine receptor, the H3. You find it in the spinal cord, which is again the junction box that takes you into the brain. It is in fact also found in the brain as well. But the important thing is this receptor, where histamine binds and controls pain transmission, is found out here in the periphery on particular types of sensory nerves. Okay, so many years ago, I approached this guy, Steve Liu. He worked for Pfizer in those days, down in Sandwich before it was closed. We won't talk about that. This drug fitted the bill, exactly what we wanted. We wanted a drug that blocks the H3 receptor that controls pain transmission in the periphery, and it's centrally sparing. In other words, it doesn't get in the brain. And this is the drug that he was working on all those years ago, and they were looking at using it in allergic rhinitis. It failed in that trial, and then that drug was put on the shelf. Okay, so we approached Steve and said, this is a perfect drug that we want to test to fit our idea of modulating pain transmission and pain without getting in the brain. So we tested this drug, and it, in fact, yes, it did what we wanted it to do. It basically reversed the neuropathic pain that you find in this particular model. This is a nerve injury model in a mouse, and it basically increased or decrease the sensitivity to a touch. I think Kirsty mentioned the filament idea in humans, so mechanical sensitivity was tested here, and this drug in a dose-dependently way reversed it almost back to a control level of sensitivity. So down here it's extremely sensitive, it doesn't take much of a touch for the paw to withdraw, but here with the drug it's almost back to the high threshold sensitivity that you saw in the controls. Okay, so in other words, it's blocking neuropathic pain in this model, and it doesn't touch the uninjured arm, which is very important as well. So it's very selective to block that receptor. We found another drug a few years later, which in essence does the same thing. In this case, it does it in a slightly different way. It actually is a very unusual chemical. It's a drug, a chemical that's released by this very humble tick fly, and the tick fly latches onto you and sucks your blood. And the reason why you don't know it's there is because it releases in its saliva some of these proteins that bind histamine with very high affinity, binds and blocks the signaling of histamine in your skin. Okay, so this is a drug that doesn't get in the brain. Again, evolution has designed this protein molecule not to get in the brain. So that's fitting what we want. We want a drug that binds histamine in this case and stops it acting on that H3 receptor I talked about. And the idea is that does this block neuropathic pain? And yes, it does. It exactly the same way. It does the same things, the same type of experiment. It mops up the histamine, stops it binding to the receptor, and then you get relief of neuropathic pain, like shown here in a nicely dose-dependent way. So if you apply this drug, again, it does what you want it to do. It blocks the neuropathic pain, peripheral neuropathic pain. It doesn't get in the brain. So there's no central side effects, no brain side effects you see with opioids, gabapentinoids, etc., etc. Okay, so we've got two drugs, clinically ready, because they've both been in humans already for various other uses. And so we've got two drugs that does this. They block the sensory signal from the periphery from getting to the brain and controls the pain signal. Okay, so that's the idea. So it's two very important drugs that we're reusing, if you like, to target neuropathic pain, peripheral neuropathic pain. And we're currently looking at this in Parkinson's pain. Now, as I think Ray mentioned, in Parkinson's you have central pain, which they focus on down in King's. This is focusing on peripheral pain. And what component of peripheral of pain is peripheral in Parkinson's is a question, and that's what we're currently looking at. What contribution of pain in Parkinson's can be blocked by these types of drugs? All right, so that's two different strategies for now. One for now, where we're actually focusing on the brain and central aspects of pain through our biopsychosocial approach, and then we've got the peripheral outside the brain that's actually going to target pain without getting in the brain and causing all the problems we have with current medication. So we've got two strategies that will be options for NICE potentially for GPs to use in their general practice. And this as a finishing point for the drugs. So we're basically going to we're designing local application of these drugs with a sort of a patch type system. So you would have a continuous release patch through a microelectrode. That's what we're currently working on with these two drugs, because you get much more effective effects of these drugs when you apply them locally and in a continuous manner. And again, that will allow for people to have these patches and not have to rely on taking pills every 5 minutes, because Parkinson's individuals have enough pills to take at the best of times. Okay, so that's a couple of our potential solutions for now and the future.
Fantastic.
And,
That's really good. Thank you, Paul. Thanks for that information. and let's hope that the future's bright for us all. I am conscious of the time, and we do appreciate that everyone's time has been given freely tonight. If we can go on to some of the questions. One of the questions that I would like to address first to Ray / Kirsty, because I believe that you're under time pressures, Ray, if I may. The questions come in, and I'll read it as follows.
Russ, just say I'm okay with time. Actually, I managed to move what I had. So
Thank you so much. Thank you. This particular person has said that they suffer with Parkinson's and Charcot-Marie tooth disease. I hope I've said that right. So it's hard to pinpoint where the pain is coming from. Now I am at a stage where I've been told that I am being discharged from the pain clinic, and they have advised me that there is nothing further they can do for me. Oh, what can I do next?
So if I can have a go at it, first, can I congratulate all Paul as well as Siva and Kirsty, fabulous talks, really fantastic. Charcot-Marie tooth disease is a very separate condition. It's a hereditary peripheral condition of the peripheral nerves. And so the origin of the pain there could be quite different to what we've been discussing in Parkinson's. It's a very complex area, really. And I suspect that if the person has already been seen at the pain clinic, they would have addressed different types of pain therapy. So one will have to go. It's very difficult to give a sort of a generic answer to this, but what we'll have to try and dissect out how much might be related to each of the conditions, and then try and address the pain management, both pharmacologically through some of the molecules that we've discussed, but also through exercise and other non-pharmacological measures.
Yeah, if I could just add to that, I mean, obviously the two drugs I've just been talking about could be a sort of ideal pharmacologically for the future for targeting that type of peripheral neuropathic type pain. So I don't know if Ray would agree, that's exactly the type of pain that we would target with these types of drugs.
Yeah, I agree. I mean, it's as you said, Paul, and I think that this is where we really need trials. We need industry to come in and high quality trials with good data that will provide level 1 evidence for people like, groups like NICE and other policymaking bodies. As you said, Paul, it's, a lot of our Parkinson's patients also, we've used a lot of opiates in the past. We've used gabapentin, pregabalin group of drugs, but as you said, that those are likely to be phased out. So we need to really think about how are we going to manage these conditions.
And in fact, I'm working with Susan actually on her pain models in Parkinson's at the moment. So we're going to be testing at least one of these histamine drugs in her peripheral in her Parkinson's models of pain.
Right.
So,
Okay. Kirsty works very closely with her.
Yeah. So we're working with Susan at the moment on that. So we're going to try it out in a pilot study at the moment, just to confirm how much contribution is peripheral. That's the thing with Parkinson's. It's a combination of central and peripheral, and we don't really know what contribution each have in a lot of the types of Parkinson's. So she was quite keen to try our peripheral drug because obviously that could answer potentially a question of what contribution is peripheral.
So how will you know that, Paul, in the sense that you've got a non-central nervous system acting pharmacotherapy?
Well, that we know the drugs don't get in the brain. Basically they are designed, and we already have evidence they don't get it. So that is the strategy. So we're going to use a 6-hydroxy dopamine model basically initially, because it works with the von Frey, the mechanical type pain. So which is exactly what I've just shown you data from. That's the sort of type of pain that we're working on.
And so do you know where those receptors are then in the periphery that you're targeting? Yeah,
I mean, I sort of showed you a sort of diagram. We have mapped it, but I mean, actually about 13 years ago, actually, we mapped, you know, where those particular H3 receptors are.
Yeah.
And as I said, yeah, one of the drugs is targeted to H3 specifically.
Yeah.
The other one could actually modify other histamine receptors because it's mopping up the histamine. So the H1 could also be a contribution to some of that signal. So yeah, so the two drugs are slightly different in their target, but it's basically, yeah, it's the sort of her readouts from her models are suitable for what we're looking at. So yeah. So yeah.
Yeah, I suppose the only problem is there's definitely a central component to the pain in that model. So it's a question of, you know, it's a question of quite how much can be inhibited through just a peripheral mechanism.
Yeah, well, that's part of the question.
It's a critically important question.
Yeah, that's absolutely right. Yeah, I mean, we know, yeah, that model, you know, there's a degree of central sensitization built into that. The CCI models, you know, that those sort of, you know, there is, and also there is certain inflammatory elements to that as well as neuropathic pain, which again is something we're interested in, you know, dissecting as well. But yeah, I mean, the beauty is the drug targets periphery, but it also may have some knock-on central effects as well, which could, you know, give it even more advantage. So I know Susan's working on the central end of things as well. So we're comparing the central and peripheral in the same model. Anyway, yeah. Sorry.
Ray, if I may ask a question, this has come through from somebody, but it also resonates very closely with what you said earlier in your presentation, as well as my own personal experience. Would you recommend having corticosteroid injections regularly to manage pain issues? And with my element, I used to get that stiffness and the pain in my right shoulder because my arm didn't used to swing in normal posture. And consequently, because I'm affected on my right hand side and I lost that arm swing, my left hip started aching, and before I was diagnosed, and I put it down to the way that I was, like, the left hip was kind of trying to overcompensate for my right side dragging a little bit. So the question was corticosteroid injections.
Yeah, it's a good one. So the point I was trying to make is misdiagnosis. So it's quite well known, and it'll be interesting to see amongst the audience. Many of our Parkinson, people with Parkinson who come to us who might have had pain at the early stage of their illness will say that their first symptom was often in the shoulder and there was pain. Now that could, in that situation, it can be misdiagnosed as frozen shoulder. Of course, frozen shoulder has its own criterion, you know, diagnostic process. And if somebody does have frozen shoulder, then steroid injection is the right way forward. But if somebody has got Parkinsonian pain, and that is, as you quite rightly said, sometimes partly contributed to by the fact that there is muscle rigidity, hence you're not swinging your arm very well, and that is sort of partially contributed. Then steroid is not the right treatment, really. Then the treatment should be for addressing Parkinson's symptoms, so both the motor and the non-motor aspects. So it's really important, and there is data showing, at least in the brain bank study I showed, that 15% of people had been referred to rheumatologists and were getting shoulder injections for a misdiagnosis of frozen shoulder when they should have been treated for the Parkinson side. So, you know, it's really important. At the same time, of course, people with Parkinson's can also get frozen shoulder. So, you know, it's a cause and effect sort of thing, and it really needs to be treated in its own merit and by the proper diagnostic criteria, by the proper specialists.
Thank you so much. Thank you.
Sorry, Russ. I just need to flag up that, you know, again, NICE considering, I mean, again, the evidence base for corticosteroid benefits have been questioned generally across, the chronic pain treatment arena. Again, Ray might be more up on this specifically, but so again, it's something that down the line, GPs may not be prescribing, corticosteroid injections. I mean, it could be maybe just for selective individuals. Again, it's very personal, as Ray alluded to. You've got to know the diagnosis, appropriate diagnosis, and whether it's appropriate for that particular type of Parkinson's pain.
Thank you.
Yeah.
Thank you. Siva, first question in for yourself, and it comes from a friend of mine. So, how can we stop the constant pain?
Well, that's definitely a physician question, but I guess Dr. Chaudhuri or somebody could answer. But one of the things with at least JOGO, I can say it's a process. For somebody to have pain relief, it takes at least 8 sessions of using JOGO. So JOGO is not like an injection that you get suddenly, the pain goes away, because you're training your brain, right? You're training your brain. So I would not recommend something like a behavior therapy, which is what JOGO is all about. It's a behavior modification therapy. It's a process, but we have seen in our studies, but the effects are mostly permanent, right? In the cancer study I showed you, even after 6 months, the patients who were alive did not experience the pain intensity that they had before they used something like this, because you're actually training your whole body to be, I talked about 3 things, the pain, anxiety, muscle tension cycle, right? You're breaking that in your body. And like right now, we are doing a study at Harvard Medical School for chronic low back pain. Some patients, even after the study is over, they said, okay, I'd like to keep this because whenever I get something, it's fun to use. I don't think it's needed, but that's something that the patients could use after they get the full treatment, right? So if you're experiencing sudden pain, I would not recommend something like a behavior therapy. It's for chronic pain, not for acute pain. Chronic pain, and it's a process that you have to use it for 8 sessions, 45 minutes a day. Typically takes 2 months of treatment, because you normally need time for the brain to think about the whole thing. So it's typically once a week. They use JOGO 45 minutes a day. Sometimes they use the next couple of days, but you still need to complete the 8 weeks of treatment of essentially using something like a behavior therapy. It's not just with JOGO. I'm saying anything that even Dr. Chaz talked about his whole program, right? Dr. Chaz, it takes time. You need to do that periodically at an interval. Then you get that. So for sudden pain relief, I would not recommend any of the behavior therapies. It's not. It's like meditation, right? It takes time for you to. Yeah.
Can I just chip in again?
Sure.
Those of the audience are in the UK. My good colleague down in Manchester, Anthony Jones, actually has a very important program of neurofeedback-based type therapies that he's developing for in-house use, so in-home use. So anybody interested, again, I can put you in touch with Anthony in that respect, because he's working, because there's a pharmacological biological basis to neurofeedback type strategies and neurostimulation and neurofeedback combinations in pain, and they've been very successful in a number of the individuals that Anthony's been working with. Again, it's very selective type of therapy, a very selected type of treatment. Yeah, so I just flag up Anthony and publicize his work.
Good.
Down in Manchester.
Just to clarify,
Yeah.
JOGO is a biofeedback, EMG biofeedback, not a neurofeedback. So just to
yeah. But he also works in that area as well. I mean,
it's the same process, but it takes the physiological electromyography signal to feedback to the loop, whereas neurofeedback, I guess it takes the EEG from the brain.
Yeah, that's what he does as well.
Okay.
So if you're interested, I mean, Anthony would be somebody you could talk to, actually.
Yeah. I mean, after seeing this, I'm coming to London to talk to some of you first to start my trial. I guess that's where I should come. And I found out
up north as well.
Okay.
and Durham and the Northeast.
Well, as we're coming up to the end of tonight's session, I would very much like to take this opportunity to thank Professor Ray Chowdhury, Dr. Kirsty Bannister, Siva, Nadarajah, and Paul Chazo. And on behalf of the Parkinson's community, I don't speak for us all, but I would like to say that on behalf of the full Parkinson's community, may we wish you all our sincere gratitude for sparing us your valuable time, appearing here tonight, and may you go from strength to strength in all you do for our community. And just a reminder to the viewers, I know it's tough times, but our friend Elizabeth Idle has a charity, Cure for Parkinson's, and she is trying to raise funds to participate in the World Table Tennis Championship in Berlin in September, subject to lockdown restrictions. And that there is the road to the World Cup. It actually goes via the German Open. So if you can't spare anything, or if there's any potential sponsors, we would gladly pass on her details. So without further ado, I'd like to say thank you. And unfortunately, we didn't have time to get all of the questions through all the questions tonight, but I'll make sure that who these are designated for will receive them by email, and we'll try and get some answers back for you. So this has been a fantastic session tonight. We've discussed living with Parkinson's and pain, and thank you all for joining us.
Thank you.
Okay.
Thank you.
Thank you all. Thank you again.
Yeah.
Thank you, Ray.
Thanks all.